Good afternoon to our lecturer, Dr. Masdi. Today we are going to present about our project, which is RAM study for gas processing plant. And our group member is MOHAMAD, me, PAVIETHIRAN, and Shah, Hafia. Okay, the project outline is presentation outline for our today's project is about diagram of analysis, objective of the analysis, and the assumption will be explained by me. Pre-performing RAM analysis and engineering and data analysis will be explained by HAMIZAN, and the final two is result and discussion, and conclusion will be explained by Shah. Okay, the background of the analysis. First, for the RAM study, we will be using live information examination. Unwavering quality designers use item live information to decide the likelihood or an ability of the parts. Okay, then we have to assess the plant risk and reliability, which is critical in maintaining a desired level of performance for what you want to assess to provide at the lower cycle cost and risk. Next, the reliability engineering covers all aspects of product life, from its conception, subsequent design, and production process, through its practical use lifetime with the maintenance, support, and RAM, which is reliability, availability, and maintainability. The reliability life data analysis, which is LDA, is used to study and modeling of observed product lives. And the last one is life data can be lifetimes of products in the marketplace, such as the time the product operated successfully or the time the product operated before it failed. Okay, now I'm going to explain the objective of the analysis. Okay, we has been assigned as the reliability engineer for this project, and our team, which is HAMIZAN and Shah, and me, has been chartered to evaluate the performance of gas processing plant in terms of reliability, availability, and maintainability, which is RAM. And we have four objectives for this project. The first one is we have to establish the assumption used for this study. The second one is to evaluate the average availability of the plant for a period of 3 years based on the failure and repair data given from the plant. The repair and failure data, which is from Weibull distribution, and the MTTF, which is mean time to failure from exponential distribution. Okay, the third one is we have to identify the critical equipment, which is the bad actors that contributes to the availability of the figures. And the last one, we have to propose an action plan that need to be done if the plant need to achieve 99% availability, and we have to justify the action. Okay, now I'm going to explain about the assumption for this project. The first one is the distribution parameter for each type of equipment is constant for the entire plant system. We didn't change the parameter because we want to be the constant value. The second one is the failure of equipments follow variable distribution with two parameters, which is shape beta and scale, which is eta. The third one is the repair of equipments follow exponential distribution with one parameter, which is mean time to repair, MTTR, and the scale used is eta and mean time to repair, MTTR parameter. The fifth one is the corrective task for every equipment is upon item failure. The cost for corrective tasks are not included in this project because we didn't receive any data for the cost. The next one is the condition for every equipment are followed from the case study from reference number 1 on chapter 8. And the last one is the observation time we took for this study is 3 years.
Assalamualaikum. My name is HAMIZAN bin FUAD. Now I will explain about pre-performing RAM analysis. So first we go to the data gathering. So data that we get from our lecturer. So it consists of the distribution parameter for failure and repair. However, there are 4 equipments, which is compressor, motor, turbine, and pump, was given the time to failure only with each failure and suspended status. So it is assumed that the data given is the reliability life data analysis LDA with right sensor data because of the suspended status. So next, we go to the approach and refine concept. So for this analysis, we choose 2 software, which is Weibull++ and BlockSim, to run our analysis. So the first one is Weibull software. The Weibull software is used to we insert the data from the TTF data, and then the software will plot the Weibull graph and calculate the distribution parameter related to each 4 equipment. So from this stage, we have complete data for the failure distribution parameter and repair distribution parameter. So next, we choose block sim software to create the reliability block diagram RVD for the whole plant system with its sub-diagram. This is our RVD for natural gas plant. From this figure, it have the subsystem block, this is the list of our subsystem. As you can see here, the green color indicate the block have failure and repair distribution parameter, while the white block, they are considered as non-failure block. I will explain about engineering and data analysis. So first, we do the data integration. After we get all the parameters distribution for failure and repair, we insert the data for failure and repair distribution parameter into block sim RBD of the natural gas plant. So the model reliability failure data follow the Weibull distribution parameter, which is shape beta and scale eta, and then the corrective task, which is repair data, follow the MTTR of the equipment. After we done the data integration, we do the simulation of our plant. So after all the parameters were set up, we can start the simulation as a whole system. The simulation was set up as per requirement, which is the observation time is 3 years. Now I will pass to the Shah.
Thank you, Pavi and Hamizan, for the presentation before. Next, I will proceed with next presentation is for result and discussion. Alright, for the first one, simulation summary. Our simulation cycle run with a 3 years life. Okay, and then after that, we obtain the ability is 97.93%. Alright, the most critical element are reflux, pump and driver motor. And then from block sim software, what we can obtain is the graph. And as you can see, the black line above is the availability, and then blue going down is a point reliability. Next, for the bad actors, we identify the bad actors by plotting the histogram. And then as you can see from the red arrows pointing at 3 parts, which is driver motor, driver electric motor and reflux pump. Because reflux pump shows a high expected number of failure and is simulated with the combination of 2 capacity of reflux pump. Okay. Then for the action plus proposal, we try to make it as possible for equipment to operate reliably, safely and optimally in a specific environment. Second one, to perform scheduled industrial inspection and maintenance tasks on regular basis to prevent equipment downtime or failure. Next, to anticipate possible equipment failure and to regularly perform inspection, calibration, lubrication, part replacement and other activities that will prevent equipment downtime or failure. Number 4, to minimize the cost of operating the equipment. And lastly, to promptly respond to equipment malfunction or failure incidents that require maintenance and repair while safeguarding the safety of maintenance personnel and technicians. After we complete this project, we use the 2 software, which is Weibull++ and Block Sim. For Weibull++ software is used to plot the distribution with the given TTF data, while Block Sim software is used to create RBD for the whole plant system with sub-diagram. From the result and discussion, simulation summary and backactors were obtained, and the main objective for this project is to evaluate performance of gas processing plant in terms of reliability, ability and maintainability. The target value to reach ability was 99%, but we managed to get 97.93%. Therefore, bad actors were identified as one of the factors that our plant ability decreasing. apart from that, by defining the bad factor, we can change our maintenance strategy from corrective maintenance to preventive maintenance. So instead of we correct the maintenance, we try to prevent it. These case studies will demonstrate the usefulness of methods and could be used by process engineers to learn how to apply RM principle in the process design. I think that concludes our project and presentation. That's all from us. Thank you.